Okay, so we are going to talk about Pangea today. And what is Pangea? Well, let's take a, we're gonna move on here. We're gonna move on here. We're gonna move on here. Okay, so scientists have tried for years to solve a mystery, okay? And the mystery was this right here. Let me show you what the mystery is. Look right here. I'm gonna show you something here. Look here. Okay, here's South America. Here's Africa. Doesn't South America look like it should have been tucked into Africa here? Doesn't this look like it would fit right in there? It does, doesn't it? Well, guess what? If here and here, this is Natal, Brazil, and this is Dakar, Senegal. That's a little country in Africa. And you know Africa's a continent, not a country, right? Everybody knows that?
Yeah.
Africa is a continent, not a country. There are many countries in Africa, okay? And look how big Africa is. Africa is a lot bigger than the United States. The continent of Africa is bigger than this up here. And anyway.
Where's Africa then?
Well, look here, here's the United States and here's Africa. So you go across the ocean, and then if you cross the ocean, you can go right here to Dakar, Senegal. But anyway, in Natal, Brazil, and Senegal, in Dakar, Senegal, geographers or scientists, actually they're scientists who are also geographers, found the exact same type fossils. Well, and it just so happened that these fossils were land creatures that couldn't swim. Okay, because the way it is right now, they would have had to, if you got the same fossils here that you got here, and they can't swim. Okay, so how would you have the same fossils here and the same fossils there? That would be odd, right? Unless at one time these continents were together, because these fossils are like millions and millions and millions of years old. So, and then look right here. Here is I happen to know what this is right here. These are like some kind of fern here in South in Antarctica. Antarctica's at the bottom there, right? And here's Darwin, Australia. Well, the same fern type plant, and ferns, by the way, take a tropical climate. If you have ferns, you're in a tropical climate. Well, is Antarctica tropical? Do they have a tropical climate there? No, they have an Arctic climate, right? That means it's cold year round. Okay, but well, here in Darwin, Australia, it's warm. It's warm there. It gets over 100 degrees sometimes. Anyway, so they found the exact same type fern plants there. Well, now that's all. And then other places they found different types of plants. Anyway, so what that leads one to believe is that if you find similar fossils in places, and there's water, a lot of water between those distances, and maybe those animals can't swim, or in one case they found some alligators, and this type of alligator was a freshwater alligator, so they couldn't have got into the salt water and swam.
Yeah, we have freshwater alligators.
Yeah, freshwater alligators, so they couldn't have got into the salt water to swim across from, I think it was South America to Africa. So that would lead scientists to say, oh, these places used to be one big giant continent. Okay, and guess what they called that continent? They called it Pangea. Okay, so scientists have tried for years to solve the mystery of how they could find these similar fossils, so far away from each other, and there's oceans separating them. So, and one proposed theory is known as the continental drift, and this concept was first presented by a German scientist named Alfred Wegener in 1912, and here's a picture of him right here. And Wegener theorized that all the continents were once connected into one large landmass. I'll show you a picture of it here shortly. And he stated that the land then drifted apart. And guess what it's doing right now? It's still drifting over years. Still drifting. And what's going to happen eventually? They're going to drift the other way, and guess what's going to happen millions and millions and millions of years from now? There's going to be another giant supercontinent. Okay? So here we are right here. So here is what the U.S. looks like now. Right? Okay? And there's the big question right there. Okay, so look right here. So scientists in the 1960s worked to prove Wegener's idea and develop this theory of plate tectonics, which is the title of your, isn't that the title of your, is that the title of your student copy? Plate tectonics? Okay, so we're going to talk a lot about plate tectonics and how that affects Earth, right? Anyway, scientists in the 1960s worked to prove Wegener's ideas and developed the theory of plate tectonics. And that theory states that the Earth's surface is broken into large, rigid plates called rigid pieces called plates that move independently of each other. Okay, and here are some pictures of them right here. Some say there are 7 major plates, then there's like 13 minor plates, and you can see these black lines right here on it. And they move independently of each other on plates of, it's called the asthenosphere. It's, when I think of it, I think of like pudding, you know, because underneath, you know, you got the crust of the Earth, right? And then underneath the crust, you have the mantle, and part of the mantle is like semi-rock. So I think of it as these plates, they're moving around on this putty-like stuff, or pudding-like stuff. So let's look right here. So it is the movement of these plates that cause changes in Earth's geographical features, including mountains and volcanoes, as well as other shapes of the continent. Okay, and here's another picture of these plates here. Caribbean plates, this happens to be the North American plate and so on, right? South American plate, Nazca plate, Arabian plate, and so on. Okay, so let's look right here. What's the, here's your first question, by the way. This is slide 13.
Oh, I know what that is.
First question. Well, mark it down. Mark the answer. Mark the answer. This is going to be your first grade here in this lesson here. So what's the outermost layer of the Earth called? Is it called the mantle or the crust? Mark your answer. That's this layer right here that you walk on. Is that called the mantle or is that called the crust? A or B? Everybody got an answer? Got an answer, Michael? Got an answer, Dakota? Terry, got an answer? Got an answer, Bryce? Got an answer, Jaleel? Okay. Let's move on here. What's the thinnest layer of the Earth called? Anybody know the thinnest layer? Is it the mantle or the crust? Here's the crust right here. Here's the mantle. Which one's thinner? Which one is the thinnest? Is it the crust or the mantle? Mark your answer. Crust or the mantle? We actually talked about this the other day, didn't we? We did. I know we did. With that lesson that I gave you. Okay, let's take a look right here. So, look, here's the continents of the world. Okay, here are the continents of the world. What's continent is this right here, Michael? What's this continent? Which one of these is it? Huh? South America. Where's Antarctica at? Come up here, Jaleel. Where's Antarctica? Show me where Antarctica is, Jaleel. Move Antarctica. Find Antarctica for me. Find Antarctica.
Right here.
Well, mark Antarctica there. Put Antarctica there. Good job. Bryce, come up here. Where's Africa, Bryce? Come up here and do Bryce for me. Move Bryce. Bryce, come up here. Move Africa up there. Where's Africa at? You can't move it on yours. You got to move it on mine. Come up here and show me where Africa is. There's Africa. Move Africa around for me. Show me where Africa is. Put that on Africa. It's okay to be wrong. It's not the end of the world.
Mr. Hughes, can you give me a hint and tell me if this is wrong or right?
It's wrong.
knew which one it is.
Where's Africa? Good job, dude. Come up here, Terry, show me where North America is. North America. Good job. Okay, so there's North America, there's South America, there's Africa. Where is Europe at here? Come up here, Dakota, show me where Europe is. Where's Europe? Europe. By the way, I'll tell you a little story. Greenland is actually part of North America.
Europe is.
Where's Europe? Europe.
Right there. Is that it?
Mm-hmm.
Show me. We'll just move it. Move Europe up there.
Mm-hmm.
Other way. Over that way. There you go. Europe. Okay. Who hadn't been up here? Okay, so Mr. Hughes got the other two. Look here. Here's Asia. Asia's right here.
Yeah.
Let me show you a little trick how you figure out where Europe and Asia is. Look here, on any map, you'll see this little river here. This river, I think it's called the Ural River. The Ural River separates Europe from Asia. Russia's right in here. Russia is partly European. Moscow's about right here, I think. Somewhere right in there. Russia has part of it's Europe, part of it's Asia. And you can always, there's your dividing line right there where this river flows down here. It's called the Ural River. There's also a group of mountains there. Once you cross those Ural Mountains, guess where? Guess where you're at? You're in Asia. Okay, and then where's Australia? Which one's Australia?
Right there. Yeah.
It's right where? Here?
Yes.
You like that right there? It's right there, right? Australia. Okay. You got it. You got
So
it.
North America is bigger than Africa?
Africa, you know, on a map, you always distort the best way to see a map is on the globe.
Mm-hmm.
And you'll find that Africa is probably bigger than North America. This is huge. Yes, uh-huh. All right, okay, all right, mm-hmm. Did you come in late, Jaleel?
Late?
Yeah, were you late today?
No?
Okay, well,
What happened?
okay. Okay, so we've got, all of our continents, right? That's the way they are now.
It's cheap.
But let me show you something here. Look right here. Compare this map on the previous page. Look at this map. This is what it looks like now. Well, look, this was Pangea a long time ago. Look right here. Compare this map on previous pages to the one below. The green represents land and modern continents are outlined. Okay, so this was all one piece of land called Pangea, one supercontinent called Pangea. And you see, look right here, South America fit right in there where Africa is. Fit right in there. Look here, North America fit right in here. Kind of at what's called the Horn of Africa. Okay. So you can kind of see the similarities, right? Okay, let's move on here. Okay, so here's what it looked like. Here's what it looked like if you were in outer space. And look what they're doing here. Look what's happening here. The continents are breaking apart. This is over millions of years this happened. Okay, and guess what? They're still moving to this very day. And eventually they're going to come back together again.
What?
Millions of years from now. Look here. Look how far. Look how they're moving. Right? They're moving apart. See how they're moving apart? Eventually, and it'll be millions and millions of years from now. You won't be around. No, maybe your great grandchildren will be around. But eventually, these continents are going to come back together. Okay, according to this theory. So Wegener's theory of continental drift popularized the idea that there was once a supercontinent called Pangea, and this large land mass broke apart slowly over 200 million years ago, creating the continents that we see today. And this image on the left gives you an idea how that transition happened. Now again, this is all theory, but it's theory based on things like fossils, right? Fossils and maybe the shape of the earth, or shape of the continents and shape of the land and so on, right? Okay, and we also got some mountains, the Himalaya mountains out of the deal, and that, we'll talk more about that. But it's all about evidence. Okay, so back on this fossil thing here. Again, this is part of the evidence of Pangea, okay, fossils. Let's look at it right here. So evidence of Pangea is this right here. Here is this, here's a fossil remain of this Cyanonathus, and that was a Triassic land reptile. It couldn't swim. Approximately 3 meters long. 3 meters is about like 10 feet, 10 or 11 feet long. And so you find it in South America, and then also you find it in areas of Africa. Now, straight across, right? And then you find, here's a freshwater, looks like a crocodile or an alligator. It was called a Mesosaurus then, and it was found in South America, and then also down at the bottom of Africa, which would make one think that because this thing was a freshwater, it couldn't swim in salt water, so those continents would have had to have been together at one time, right? Those lands there. Look right here, and there's the ferns that I was talking to you about earlier. It's called Glossopteris. It's a type of fern. It's found in Antarctica, and also some of it's found in South America. Some of it's found in Australia. Look at this right here. There is this Lystrosaurus. It's a land reptile. It was found in India. It's also found in Antarctica. And it was also found in Africa. Okay. And the only way it would have been found, because these are land reptiles, they wouldn't have been able to swim the oceans. And the only way they would have been able to find them in all these different places if that land was connected in some way or another at one time. Okay. So that's some evidence of Pangea. Okay. Here's your first question right here. Or actually, it's the third question. So here's our third question here. Similar Mesosaurus fossils would be found in which two areas? Look right here. Here's our Mesosaurus right here. What two areas were they found in? Look right here. Look on slide 19 for the Mesosaurus. What two areas? Okay, was it South America and Africa or Australia and South America? You can choose B or D. Mark your answer. Look on slide 19 to find your answer. Similar Mesosaurus fossils would be found in which two areas? Would it be Australia and South America or South America and Africa? Mark your answer. Everybody got an answer? I'm moving on here. So let's look at more evidence of Pangea. So even though the continents shown above are now many miles apart, when they were all together as one supercontinent, Pangea, that was the name of the supercontinent, Pangea, the plants and animals were able to spread across these modern barriers, okay? And this causes there to be similar fossils in these now far apart continents, okay? So that makes sense? Anybody have a comment or question about that? Okay, so that's some evidence of how we know that these continents would have had, these land pieces would have had to been connected at one time or another. Okay, so let's look at more evidence of Pangea. So notice that a fern called Glossopteris, and that's down here, this fern right here, was once inhabited the land that is now Antarctica. And that plant is a tropical. Anytime you find that plant right there, it's gotta be a tropical area. So at one time, Antarctica was a tropical area. And I've also read that they found palm leaves in Antarctica as well. Palm leaves, fossils. Where do you find palm trees? In the desert, right? Desert areas, like desert-like areas. You find like California, Arizona, a lot in the Middle East. Okay. Okay, so here's some more evidence of Pangea. Look right here. There are non-living clues. Those are living clues, right? We found fossils of them. Those are living animals that once lived and thrived in those areas. So there are non-living clues that support this theory as well, okay? The rocks that make up our Earth hint at the fact that Pangea once existed. For example, look here, the Appalachian Mountains right here, that's on the left here. In North America and the Caledonian Mountains in Europe are similar in age and structure and are made of the same rock types, okay? Very similar. And let me tell you a little story about that. The Wichita Mountains out here are made similarly as the Appalachian Mountains. They're about the same age. And these right here, the Appalachians, they're among the oldest in the world. Same way with the Caledonian Mountains, they're older, although I suspect that the Caledonians might be a little bit younger, but very similar, okay? They're made of the same rock types. Okay, so here's another question here, number 4. So, which can be used as an indicator of past climate and weather? Fossils or mountain ranges? A or C, mark your answer. Which can be used as an indicator of past climate and weather? Fossils or mountain ranges? Mark your answer. Everybody got an answer? I'm going to move on. Okay, which of the following can be used to show continents used to be next to each other in Pangea?
You said number 4 can be either what?
Number 4 is either fossils or mountain ranges. Okay, look right here. Which of the following can be used to show continents used to be next to each other? How about fossils? Would that be an indicator? We saw right over here. Look right here. Look right here. We saw it. They're similar, right? Fossils. How about this right here? How about similar animals? Are these similar animals? Same animals that were here that were there, right? Got the idea? How about mountain ranges? Look here. We just showed that these are similar mountains, right? Okay. So what's the answer here? It's more than one. It's more than 2 answers. It's more than 3 answers. So what's your answer? Mark your answer. It's 3 answers there. So mark your answer. Don't miss number 5. There are at least 3. There's 3 answers there. So mark your answer. Okay, I'm moving on here. Okay, so let's look at the motion of the continents. Motion of the continents. Okay. Let's look at the motion of the continents. Okay. Okay, so Pangea was not the only, listen to this right here. Pangea was not the only supercontinent that has formed on Earth, but it is the most recent one, okay? You remember the Earth is like what, 4.5 billion years old? So look right here. This above image shows the land was distributed around 600 million years ago. And then, so look right here. This was 600 million years ago, what it looked like. Let's see what it looked like.
With the Earth?
Yeah, this is what the Earth looked like 600 million years ago.
How did they know?
Okay, huh?
Are they gonna use Jurassic?
This was 600 million years ago. This is what the planet Earth would have looked like.
Was people even
According to, at least there's no evidence of people up to this point. Okay, it's 600 million years ago, no evidence. We'll have to Google to see the earliest remains found, but now the earliest remains found, does that mean that was the earliest humans? It's all theory. If you do it 2 minutes or less, I see a pattern here. Okay, so this image shows how the land was distributed about 600 million years ago. Well, 2 to 300, that was 200 to 300 million years before Pangea, okay? And remember, Pangea is the other way, they're all together, right? This right here shows them super far apart, right? Okay. And this looks like, heck, I don't know what that looks like. That looks like it could have been part of Alaska right down here, I don't know. Anyway, so let's move on here. So, changes in the land, okay? So the continents below are still moving. The continents below are still moving, but we don't notice a difference because of how slow the changes occur, okay? And then, so not only are we going 1,000 miles around, but we're also moving on these plates, right? Usually, well, we're not gonna do that. Let's answer this question right here. Which of the following statement is not evidence of continental drift? Not evidence, not evidence. The other three are evidence. Okay, the other three are evidence. One of these is not evidence for Pangea. Would it be similar fossils, matching coastlines, similar present-day weather, or matching mountain ranges? There's only one of those that is not evidence of the other three we've talked about. Okay, I'm gonna move on here. Everybody got an answer? Okay, actually, we're gonna stop right there. We are gonna stop right there, and I've got we're gonna look at something else here. For you at home, answer those questions, and I'll let you know when you're gonna turn that packet in, and we'll have another video for you tomorrow. We're gonna talk about energy flow.